Hey everyone, today we're going to take a look at dimensional analysis. Don't let the words freak you out. I know that this is math that you've done all through elementary school and middle school as well. When we're looking at dimensional analysis, what we're really trying to do in math is do some unit conversion. So let's take a look at some quick examples about how to convert some units. What I'm going to take a look at first is going from grams to kilograms. Now, we know from lab already that taking grams can be recorded from using the scales in class. So we might have a sample, it could be a powder, it could be some kind of other solid, and we want to know how much it weighs. When we put it on the scale, that's going to give us grams. But let's say we've got a lot of grams. Once we hit 1,000 grams, that's going to allow us to roll over to the next highest unit, which is going to be kilograms. So let's take a look at an example where we might want to take a big number of grams and switch it into a smaller number of kilograms. Let's say I've got a really nice scale and I put some beans on it, and the beans come out to weighing 2,439 grams. When I'm doing calculations, don't really know what calculations I would be doing with beans, but let's be hypothetical here. If I'm working with 2,439 grams of beans, I might want to convert that into a unit that gives me a number that's a little bit easier to work with. So what I'm going to do is convert it into kilograms. The way I'm going to do this is take my number, let me make it a little bit smaller here, and I'm going to put this into an equation. The first thing I'm going to do is put my multiplication, and then I'm going to put a fraction here. Now, there's nothing in the fraction, and remember that the top is the numerator and the bottom is the denominator. So let's recap that. Remember, the top, that is going to be numerator, and down below, we're going to have denominator. So we're going to have to find some numbers to put in there. Well, what I'm going to do is start by filling in my denominator, because the number that is going to be the denominator is going to have a unit that matches what I am starting with. So when we look at a problem like this, what we'll want to do is take a look at what we are starting with, and then we also want to look at what we are trying to find. If I'm looking at this, I'm starting with grams, so my grams are also going to go down here. For something to go in the numerator, I'm going to look at what I'm trying to figure out. In this case, it's going to be kilograms. I'm trying to go from grams into kilograms. So if I come back over here, I'm going to have my grams is what I'm starting with, and then I'm going to switch it into kilograms. So I'm going to put that in my numerator. Now, I've got units, but I need some kind of digits, some kind of numerical value to work with here. Now what I've got to do is figure out how many grams are in a kilogram. This is going to be really easy for you to figure out. So there's a few ways you can do it. What I recommend, because we're in the 21st century, is just look it up online. You can ask the assistant on your phone, so Google, Siri, whatever. You can just look it up directly on the internet in a web browser, or if you wrote it down in your notes, reference it from that as well. So I'm just going to remember, you might have to look it up, but that's fine. Remember that for grams into kilograms, we're going to have 1,000 grams for every 1 kilogram. That's because 1,000 grams makes up a kilogram. So that's going to be what I put in for my numbers here, and we call this a ratio. So my ratio for 1 kilogram to grams is 1 to 1,000. Now, to take my original 2,439 and get it into kilograms, I'm just going to do the math here according to the order of operations. let's see, let's line this up. Now, what I'll have here is 2,439 times 1, which is going to be 2,439. In my denominator, let's rewrite that. In my denominator over here, there's nothing over here. So when there's nothing in here, we get to just assume that it's a 1. So what that leaves me with is 1 times 1,000, which is going to give me 1,000. That leaves me with this weird fraction at the end, 2,439 divided by 1,000. But let's talk about what we just did here. When I've got something in my numerator and in my denominator and they're both the same, I get to cancel them out. So if I take a look back here, I've got grams here and I've also got grams over here. So 1 is in the numerator and 1 is in the denominator. That means I get to cancel them out and they go away. The unit that I'm left with is my kilograms. So because I've got a unit that I'm left with, that unit is going to follow me into my answer. So I'll have 2,439 kilograms divided by 1,000, and when I simplify that number, I'm going to end up with 2.439 kilograms. And you might be working with some kind of significant figures, and depending on what your scale is or what other calculations you're using this number in, you might need to round it, right? So let's just say, for the sake of this example, I'm going to want to keep 1 decimal place. I will just rewrite this as 2.4 kilograms. So depending on the problem, it might be easier to work with 2.4 kilograms compared to my original 439 grams. My next conversion here is going to be going from milliliters into liters. So let's take a look at an example here. Let's just say, let's talk about soda. So if I've got 2,000 milliliters of soda, and I want to know how many liters that is, I'm going to do the same type of unit conversion or dimensional analysis. So I've got my 2,000 milliliters, and I'm going to set up my conversion factor. So I'm going to put my multiplication, put in my fraction here, and then we'll see what it equals. Now, I've got this empty fraction, and I've got to fill something in here. Remember that I'm going to take the unit that I'm starting with, because I'm figuring out what I'm starting with and then determining where I'm going. So I'm starting with milliliters. That is going to go in our denominator. Now I've used up my milliliters and I know that I'm trying to figure out liters. So I'm going to take my liters and plug them up in my numerator. So if I take a look at my equation here, I've got 2,000 milliliters, and I'm trying to figure out how many liters is that going to be. Well, again, you could use the power of the internet, your phone, or look it up in a chart in your notes and figure out how many milliliters are in a liter. And I'll give you a hint, it's 1,000. So I'm going to take my 1,000 milliliters, and I know that in 1 liter, there's 1,000 milliliters. So 1,000 milliliters makes up 1 liter. Now, I've got my numbers plugged in and I've got my units. I'm going to cancel out the units that are going to cancel from my numerator and my denominator. So I see my milliliters. I've got 1 up top and 1 underneath. So these are going to go away. And the unit that I'm going to be left with is my liters. So if I solve this problem here, I'm going to have 2,000 times 1, which will give me 2,000. And then I will have 1,000 in my denominator. So if I simplify that, that is going to give me 2 over 1, which we could just rewrite as 2. Now I can't just put 2 as my answer because I'm also left with another unit, remember? So I'm going to come back up and get my liters. and these are going to come down here, so I will have a final answer of 2 liters. Now, our last conversion that we're going to talk about is going to be a little bit more applicable to our everyday lives in the United States. So what we've done so far is 2 conversions that were already in the metric system. But if you live in the United States, we use what we call the imperial system. And that would include things like inches, but maybe you need to know how many centimeters something is. So let's say we took a measurement of a board and we got, 85 inches for a board that we're using for a project. I'm going to have to take the 85 inches and maybe I need to convert it into centimeters. So if we're getting our original instructions for whatever we're building from somebody in Europe, they're going to give us something in centimeters. And we may need to know how many inches that is, or vice versa. So let's just say I've got an original measurement of 85 inches. What I'm going to do is use my dimensional analysis to switch it from inches into centimeters. So again, we're going to set up our equation here, and we're going to put our multiplication, and then we set up our fraction. That's going to be where we put our unit conversion factor. So if I'm starting with inches here, don't forget that I'm also going to take the inches and put them in the denominator because that's what I want to cancel out. That's what I'm starting with, so if I see it in my original number, I'm going to cancel it out by putting it in the denominator. The unit that goes on top is the one that I want to convert to. That's what I'm trying to find. In this case, I'm going from inches to centimeters. So centimeters will go on top. Now, I've already got the number that I'm starting with, and the thing that I've still got to figure out is how many centimeters are in an inch. Again, use the wonderful power of the internet or your phone to figure that out. In this case, our centimeters to inches is going to be 2.54 centimeters for every 1 inch. Now all I've got to do is follow my order of operations and do the math. So I'm going to take my 85 times 2.54. 85 times 2.54. That's going to give me 215.9. If we look at our denominator, I see that I've just got a 1 down there, so that gets to stay the same. And if I have anything over 1, I just get to leave that out of my fraction. So if I rewrite it in an easier to read format, it's going to be 215.9. Now, don't forget, when I have units in the numerator and the denominator, I get to cancel them out. So my inches up in the top and the bottom are going away. That leaves me with centimeters, and that's the unit that's going to follow us into our answer. So 215.9 centimeters. All right, so that was a brief overview of dimensional analysis or how to do unit conversion. See you guys later.